Welcome to Edureka. This is Anuj. Today, what we are going to do, we will start with Hyperledger. We will see that how do you compare the traditional blockchain and a business network? What is Hyperledger project? What is the architecture? How do you achieve consensus in a Hyperledger network? What are the different API and application models that are available? What are the different kinds of network topology that you can have in Hyperledger? What are the different projects? So Hyperledger is a basically name of a common group, and it has got multiple projects or multiple blockchain stacks: Fabric, IDE, Iroha, Sawtooth, and what is the business network deployment on Hyperledger Composer Playground. These are the topics that we will be covering in this module. So let's first try to understand, what is Hyperledger and how does it differentiate from Bitcoin and Ethereum that we have already covered, and what are the core features and why do we need Hyperledger. Basically, as I mentioned earlier as well, the blockchain primarily is a technology where multiple participants interact with each other and come to a common agreement to achieve the consensus and update the distributed ledger. This concept initially was limited to the public domain, where you create a system where anyone can come, subscribe the service, become the member, and have the copy of the database with himself or herself, and then start transacting onto the system. And majorly it was for the financial industry or cryptocurrencies. Now, when it was seen that it can be extended beyond financial services, cryptocurrencies, and maybe it can be incorporated within an organization or within a certain set of people, rather than giving the public access to everyone, because especially in the business scenarios, you cannot give the access of your data to all the participants. So that's when these permissioned or private blockchains came into the existence. Already I gave you one example of 𝐂𝐝𝐻, another one is 𝐸𝐻, which is quite similar to Ethereum. But the leader in this domain of permissioned and private blockchain is Hyperledger. Now, what is Hyperledger? Hyperledger is basically a group of products which are designed by a open source company called as Linux Foundation. Linux Foundation is an open source company that gave birth to all these standards of permissioned blockchain. So Hyperledger has got many products, like there is a Hyperledger Fabric, Hyperledger Sawtooth, Hyperledger IDE, Hyperledger Burrow, Hyperledger. Many products are there, Caliper, etc., etc. But all these products have their own different features based on which you will use them. But the most famous among these are Hyperledger Fabric and Hyperledger Sawtooth. These two are also developed by multiple organizations. So Linux Foundation is basically a group of more than 100 companies. I think 125 members are there, and all top companies in the world like IBM, Intel, Accenture, Dell, Microsoft, they are all part of it. And they are jointly developing these standards. And because so many corporates and so many big names are associated with these, so therefore we see very frequent revision of these standards. And the one which is documented in Edureka is, I think, version 0.6, and it was not long back this version was the prime version, but now it has gone from 0.6 version 2.0, which was released, I think, a few weeks back only. The growth and development of Hyperledger based standards is enormous, because there are a lot of industry experts which are working in this area, and the due attention on these blockchain technology is huge, because they are the ones which are primarily used in industry. So if you will think about creating any kind of a blockchain which is generalized, can be used by anyone in the public, you will probably use Ethereum to create it, because it's simple, it is easy to create, and it is very simple to scale and deploy. Hyperledger, if you create a public network, it will add a lot of complexity, which is not required in a public network, and it will not be easy to deploy. Hyperledger is much more complex than any other blockchain stack that is available, both in terms of creating the smart contract, creating a network, deploying the network, making it live for the customers, doing the testing. It's much, much more complex than any other blockchain stack that is available. So generally people reach out to Hyperledger only after doing Ethereum, 𝐂𝐝𝐻, 𝐸𝐻, all these fundamental stacks. So once they are well versed with it, then only they touch upon Hyperledger. because it is considered much more complex than any other this thing. So Hyperledger is basically used for business, private, and permission network, as we have already discussed. One of the key feature in any kind of a business network is that only the valid users can enter that business network. So you need to have components that enable user IDs and their authentication. All the users which are becoming the part of this network needs to be authenticated. And entity in Hyperledger which authenticates these members is called as membership service provider. And not only the users, even the peers that are going to get added will also need to be authenticated. Each and every entity, whether it's a peer, whether it's a user, whether it's an application, everyone will need a authentic entry before they can get themselves registered into the system. So each one will need a certification, and MSP uses the certification authority, which is also built in Hyperledger Fabric, to get these certificates and give these certificates to various entries. So there are two things. One is your MSP, membership service provider, which basically keeps track of who needs to access what privileges can be given to, and who all can access the network. And then there is a certification authority, which basically issues the certificate on the request of MSP, so that those certificates can be given to the respective nodes, peer, or individuals who are becoming the part of the network. One of the key differentiator is from Ethereum and Bitcoin is there is no cryptocurrency in Hyperledger. So there is no concept of cryptocurrency. There is no transaction, no gas, no ether, nothing of that sort in Hyperledger. Even if you want to create, it is not easy to incorporate the cryptocurrency. So generally, if you want to incorporate a system where you have a cryptocurrency or you need a tokenization, you generally wrap it up using the Ethereum plugins that are available in Hyperledger. So for implementing the tokens in a business network, you generally depend upon Ethereum or Quorum that, and then you integrate it along with Hyperledger Fabric. Those kind of integration tools and mechanisms are available by which you can integrate Hyperledger with Ethereum for specifically for using tokens or cryptocurrencies. One unique aspect of Hyperledger is that each and every entity is modular. So it's kind of a plug and play. So for example, there is a default certification authority that comes with Hyperledger Fabric. If you want to use your own certification authority, it's just a plug and play kind of a system. In a configuration file, you can mention that I want to use this certification authority rather than using the default one. Similarly, by default, if you are given a Byzantine fault tolerance consensus algorithm, but you want to use some other consensus algorithm of your choice, you can just take the original one out and put your own consensus algorithm. So if you see that way, everything is plug and play. So therefore, everything is modular in nature. You can just take out any default component and put in any component of your choice, depending on what business problem you are trying to solve. The next thing which is different is consensus. Consensus, as I mentioned, the way it works in Hyperledger is completely different than the way it works in Ethereum and Bitcoin. There is no concept of proof of work. There is no concept of proof of stake. Generally, the consensus is driven by the individual nodes who are responsible to authorize that transaction. And those individual nodes are known as endorsers. And the distribution of the blocks are given to the special nodes, which are called as orderers. So the way consensus is achieved in a Fabric network is completely different the way it is achieved in Ethereum or Bitcoin. And the key reason, we have a much simpler consensus here is because it is a private network where all entities are known. So I already know that, whom can I trust to basically authorize this transaction. For example, in a land registry environment, I know that, this node is a registrar node and he is the authorized person for signing off a registry or to authorize a land deal. Similarly, in a medical domain, this particular node is an authorized doctor. He can he can update my medical records with a new recommendation or with a new medical test. So similarly, all authorized users which are authorized to initiate the transaction or which are authorized to validate the transactions are given this responsibility of endorsing the transactions, and those are called as endorser nodes. So we have endorsers, we have orderers, and then we have committers. So there are three different kinds of nodes which are available. Then there is a concept of channel, which is not there in any other kind of a blockchain. within a single blockchain network, okay, you can run multiple networks together. So for example, there are say 5-6 different departments in an organization. One is your finance department, another is your HR department, the third is your operations department. And although there are some entities which can exchange information among themselves, but not all entities should be seeing that information. For example, if HR can only disclose the salary information to the manager of the operations team and not to the entire operations team. So there can be selective sharing of the information, and then there can be nodes which are part of multiple channels. See, for example, the HR is designated as one channel, the operations is designated as one channel. There can be nodes which are part of both the channels, which can have the information both from the operation side and as well as from the HR side. And then the operations team will not know that this data is also existing with this particular node. The Linux Foundation is the body which is running this Hyperledger set of standards. So if you see, this is the main website of Hyperledger, which says advancing business blockchain adoption through global open source collaboration. And this is getting changed day by day. Even if you see this site, you will find daily new things coming up. These are the projects. These are also increasing day by day. The one that we will be concentrating is Hyperledger Fabric. This is the most widely used Hyperledger instance that is used for a permissioned or a private network. The next one which is famous is Sawtooth. The rest all are rarely used. You can see that this is the Hyperledger website. These are the various products. Then extensive documentation is available for all the products. So if you select, for example, Hyperledger Fabric, you can go to various videos, you can go to various kind of tutorials, data sheets, some of the open source projects which are going on where you can directly participate. You can download the code, you can see, you can build everything from scratch. So this is a very informative website that they have created. And if you go to build your first network, it will direct you to the documentation of Hyperledger Fabric. So the documentation is also very detailed. It tells you each and everything about how the architecture looks like, what are the different entities in a Hyperledger network, how do they interact with each other. So it's a very, very detailed architecture. Let me try to explain you using the diagram. Let's say this is my blockchain network. Now I can have different things apart from the blockchain network. I can have client application and I can have different users as well. Like for example, user 1, user 2, etc. Let's say this is the typical scenario where I have multiple users. I have a client application that are accessed by multiple users based on their credential. And then this is my blockchain network where all the nodes are connected with each other in distributed manner. The fundamental of blockchain will still remain intact. These nodes will be connected with each other. So now what will happen is there are some additional entities here. Like one is your MSP or membership service provider. So what it will do is it will keep track of what access is required for whom. For example, it will basically provide the authentication that first of all, what all members are part of my network. Is this node part of my network? Is this node part of my network? In case all these nodes are part of the network, they will need to get the credentials from membership service provider. All of them will need to register to the membership service provider, and membership service provider will give them the credentials which they will need to register before they become the part of the network. And not only the nodes, even the client application will also need to do the same, and even the users will also need to do the same. So MSP is one body which is giving you the credentials to basically join the network. And what level of rights do you have? Can user one initiate a certain type of transaction? Say for example, if in a medical domain you are a nurse, can you actually authenticate a medical record? You cannot. So what kind of credentials each user has will be stored in a membership service provider. This membership service provider takes the help of certification authority or CA, basically provide the certifications to different members. So for example, if it finds a client application has certain attributes, accordingly it will ask for the certificate from CA and it will give it back to the client application. so that the client application can authenticate itself and do the transaction that it is authorized to do. Now, considering that this is well understood, let's remove these lines from here. Now, in a typical scenario, what will happen is that your client application will basically interact with the blockchain network. And in a generalized scenario, what will happen is that it will send the request or it will send the transaction to a particular node, and then it will get distributed to all the nodes. That's how it basically happens in Bitcoin and Ethereum. In Hyperledger Fabric, it does not happen like this. So what happens is, in case a client application has a request for a particular transaction, it only sends it across to a certain nodes, and those nodes are called as endorser nodes. Endorser nodes are those nodes which basically endorse any transaction. Endorse transactions means they validate whether the transaction is correct or not. So what will happen is, let's say in my network, these two are my endorser nodes. You can have any number of endorser nodes in your network. It depends on what kind of endorsement policy you have. For example, if somebody is writing a medical record in your blockchain network, you can have 2 or 3 doctors validating it. Or maybe along with a doctor, you want to get it validated with your medical insurance company as well, whether the correct medical record is getting updated or not. So depending on how many endorsers, what all endorsers you want, you can have as many endorsers in the network. So let's say in this particular illustration, this is an endorser and this is also the endorser. Now, based on how many endorsers you have, you can have different kind of endorsement policies. Now, what is endorsement policy? Endorsement policy is that how endorsers will endorse the transactions. For example, if there are 2 endorsers, I can have a endorsement policy that even one of them is able to verify that the transaction is correct. I will mark that transaction as complete. I can have an endorsement policy that both of them needs to sign this transaction as valid transaction. Then only I will accept this transaction as complete. So depending on what kind of endorsement policy you write, based on which your transaction will be accepted or rejected. So what happens is that client application will send the request to these endorsers, endorser 1 and endorser 2. It will send the request that okay, I want to perform a certain transaction. Say the name of the transaction is T1. Say this transaction is basically updating the land record. There is a sale request of a particular land record and client application is sending that request to the endorser. Now what endorser will do? Endorser will check the database. So endorser will have the blockchain database, and how it will check the database? It will run the smart contract. Now the smart contract in Hyperledger is called as chain code. So you will not hear the term smart contract in Hyperledger Fabric. The term which is used for a smart contract is chain code. So what endorser will do is, it will run the smart contract on this transaction. It will see whether this transaction is a valid transaction or not. For example, if there is a land sale request, it will check from the existing database whether this land is qualified for the sale or not, whether the price which has been mentioned in the transaction is the valid price for that particular land or location, whether this is eligible to be sold out or not, whether it is an industrial land or a domestic use land. So all these kind of things can be checked by the endorser node, and they will reply with the read write set. So they will reply that okay, whether this is a valid transaction or not. They will get the transaction request and both of them will reply that with the validity of that transaction. So they will reply with the read write data. They will tell that okay, this looks like a valid transaction and you can update it into the ledger. But it has still not been updated into the ledger, not even in the ledger of endorsers. Endorsers are just letting the client application know that this is my endorsement result. So we have learned 3 different terms like MSP, certification authority, and then endorsers. Now the client application get these endorsed transaction along with the sign of endorser, a digital signature that this particular endorser has signed this transaction. Now there is another set of special nodes in Hyperledger which are called as orderers, and orderers are represented like this. So basically ordering is represented as a service, but they are nothing, but they are special nodes. So this is how you represent orderer. So now what client application will do is it will send these validated transactions to the orderer. These are all validated transactions. So just remember one thing, that in Hyperledger network, the smart contract is only running on endorsers. A smart contract is not running on orderers. It is not running on these remaining nodes. These remaining nodes are called as committer nodes. The smart contract is only running on endorser nodes, and the rest of the nodes only have the blockchain database. They are not running the smart contract. So the endorser nodes once verify that the transaction is correct, it will give it to the ordering service. Ordering service, what it will do is, ordering service will create the block. It will create the block from the transactions and it will distribute the block to the network. So it will basically send it across to various nodes that are connected, including the endorsers. It will send this transaction to all the connected nodes. So there is a dedicated ordering service which will keep waiting for the transactions from the client application, and they will create the block from the transactions and they will distribute the block. There can be different kind of ordering service. For example, there are three prominent ordering service that we use. So they are Solo, Raft, and Kafka. These are the three prominent ordering service that you generally use. Solo is where you just have one node which is creating the blocks and distributing it across. Raft and Kafka are fault tolerant services where you have multiple nodes creating the blocks, running some kind of a Byzantine problem algorithm on those transactions before getting them distributed to the entire network. Now, when these blocks are received, so these blocks will be received by endorser also. These blocks will be received by these nodes. Now, these nodes are known as committer blocks. What they will do is they will get the block from ordering service. They will verify whether the transactions that are part of that block are endorsed by the endorser or not, whether they have correctly been distributed by the ordering service or not. And once they verify this information, they will update their blockchain database, and the transaction will be committed to the blockchain. So this is the overall flow of your transaction in a Hyperledger Fabric network. You have endorser, you have orderer, you have committer, you have client application, you have membership service provider, you have certification authority. All these things are integral part of any Hyperledger Fabric architecture that you will hear of. And what you are achieving is you are achieving a throughput of 1000 TPS. In Ethereum also you are able to achieve maximum throughput of 300 TPS, 300 transactions per second. In Hyperledger Fabric, you can achieve more than 1000 transactions per second worth of speed. There is no overhead anywhere. You don't need to deploy smart contracts at all the nodes. The minimum database is kept in the blockchain database. So again, there are three categories of database here. One is your blockchain database. Second is your world state information, world state database. World state database can be your 𝐂𝐞-𝐁𝐝 or level-DB. And third is your file system based database, which are your external storage that can have your IPFS or 𝐿. So these are the different kinds of database that you can have in Hyperledger Fabric. Your blockchain database is the set of transactions or the blocks. The world state database is the recent state of all those transactions. So world state is also updated when you update the blockchain database transaction. And then you can have the individual files stored in different kind of distributed file system like IPFS or 𝐿, and they can be connected with the blockchain database because we can store the signature of these files in our blockchain network. So this is how your Fabric networks look like. So smart contract is known as chain code. Then each and every protocol. So the messaging protocol also is plug and play. Like you have Whisper and others. So that is also plug and play. This algorithm of creating the hash is also plug and play. So you can have any kind of an algorithm that you want. Now let's try to understand the concept of channel. Now there can be some nodes which are part of basically two different networks. So for example, if this node is also linked to, so let's say this is my red channel. This entire network is my red channel. It has its own database. Say for example, DB1, a blockchain database. Each and every node will have that particular database. each will be having this DB1. Now there can be other networks which might need these nodes. Maybe this is a committer node here, this might be endorser node in some other network. So you can take an example of if you have two different blockchain networks or two different hospital chains which are not interacting with each other, and there are doctors which are associated with both the networks, they will have the common points in both the networks, right? So they will be part of multiple channels. So what is happening in the latest versions of Hyperledger Fabric is there are a lot of new concepts that have also come along with whatever we have covered. For example, there is a concept where this ordering service can only distribute the transaction to certain nodes, and then those nodes will distribute it further to the entire network. Because in case you have a large network, say hundreds of nodes are connected, cannot give the entire load to the ordering service, or you will need to build a very heavy ordering service to basically distribute the block. There are newer and newer concepts coming in the latest releases of Hyperledger Fabric. Now, one more thing that you need to basically keep in mind is that whenever you are designing a business network, you need to keep in mind three things. First is your asset. Asset is basically what you are looking to transact. Your medical record can be asset, your land record can be an asset, your gold can be an asset, your money can be an asset, your intellectual property can be an asset. So Hyperledger Fabric lets you define the asset. In Ethereum, you cannot define the asset. Everything is measured in terms of ether. So how many ethers you are transferring in the transaction is basically your asset. But in Hyperledger Fabric, you can define the asset in a structure that, okay, this is my asset. My land record, which means my house number, my registry number, all those things can come as a asset. Whenever you are designing a blockchain network, especially Hyperledger Fabric, you need to first think of that, what assets are part of this network. Second thing is participants. So when you know that, okay, these are the assets, then what all participants will be there in my network. So for example, in a medical domain application, your patient is a participant, doctor is a participant, your insurer is a participant, your drug supply person is a participant, your research organization which are doing medical research is also a participant. All these are participants, and you will need to define all these participants when you are defining the network. So in the Node.js, there are named structures which are given to define the assets and to define the participants. Similarly, you will also need to define the transactions. Transactions is basically what all transactions can take place between these participants catering to these assets. So for example, there can be transaction where a land is getting transferred from one owner to another owner, or where the medical record is getting updated for a particular patient. So I'm giving you these two examples because these are easy to understand. You can think of any other example, basically where some kind of a e-commerce trade is happening, any kind of a transaction that you expect this network to perform, you will need to define it under transaction head. So these three are different structures that you will need to create in your model file before you define your blockchain network. And then the fourth thing is events. So when you want to inform about these transactions taking place to the third parties or to your GUI application, then you write events, and in the event handler you mention that what information you want to send it across. The events is similar to what we did in Ethereum. And then you have transaction handler functions. Now these transaction handler functions are basically your chain code or your smart contract, and they are written in Node.js. They're primarily written in Node.js, but the good thing about Hyperledger is it gives you SDKs in almost all programming languages. People prefer to write it in Node.js because it is simple to do so in Node.js. But you can also write it in Java. You can even write it in C++. You can write it in Python. All those SDKs are available. You can just need to plug and play and integrate that SDK and start using your language that you want to implement in your smart contract. So this is basically some basic theoretical concepts of Hyperledger Fabric. Now the key problem is that, in a traditional network, they are sharing information with each other in a inefficient, expensive, and a vulnerable way, maybe by emails, maybe by unsecured transactions, and then there is a problem of reconciliation, etc., which is solved by using the blockchain-based network, where you have the consensus, provenance, immutability, and finality. Blockchain, I think we already know that we are able to create a highly efficient distributed business network. We can do the codifications of contract, compliance, and certifications will redefine how the trust is embodied. Efficient and accessible marketplace built on blockchains will accelerate the exchange of information and value. Now, these four things are key characteristics of blockchain for business. One is your shared ledger. Shared ledger is nothing but your distributed ledger, which is same as any other blockchain ledger, where you are storing all the transactions. Another is your smart contract, which we call it as chain code. The third is your privacy. So privacy basically means that your transactions are secured. Your data is only visible to the person who is authorized to view that information. So although you can keep a database of all the information, but it should only be visible to the person who is authorized to see and use it. So the concept and notion of privacy is really, really important. And because of this privacy concept only, we have this concept of multiple channels and private data collections, etc. in Hyperledger Fabric. And then you have this notion of consensus where all parties needs to agree. So there are different kind of consensus algorithms that are being used in Hyperledger Fabric. Now, what is Hyperledger? Hyperledger is the product coming from Linux Foundation. Linux Foundation is one of the biggest body in the world which promotes open source products, and Hyperledger is one of their projects for creating a permissioned or a private blockchain. So hosted by Linux Foundation, the experts at accelerating open technology development and commercial adoption. It is neutral and collaborative, so anyone can become the member of the Hyperledger consortium and start to contribute to the network. It gives you this industry standard blockchains by business for business. Hyperledger blockchain technologies emphasize on supporting different levels of access, sub-universal validation, cross-chain transaction, and modularity. The unique advantage of Hyperledger Fabric is, these are some of the advantages. One, you have the permissioned membership. You have rich queries over immutable distributed ledger. So you can write a query file. I think I missed it here. Apart from assets transaction, assets participant transaction events, you can also define query. Query is a special file where you can define the SQL-like queries of what information are you expecting from this blockchain at any point of time. So those are your queries, and those are rich in nature because you can define a simple SQL-like queries for the reporting purposes. Then you have the modular architecture supporting plugin components. So each and everything in Hyperledger can be plugged out and plugged in based on your requirement. Protection of digital keys and sensitive data. Okay, so you have separate modules for protecting your keys, like your certification authority is a module that is specifically kept for securing your keys. You can have your own certification authority if you don't want to use the Fabric CA for authentication. Data on need to know basis, performance, scalability, and level of trust, and permission membership. These are some of the key attributes of Hyperledger Fabric. Now, what are the problems with the existing blockchains, especially the blockchains that we have seen till now? They have a limited throughput. So, they are giving the blocks after a certain interval, while, in a business network, you generally expect real-time output. Slow transaction confirmation, same thing. Anonymous processors, so anyone can join and can try to manipulate the network. No settlement finality, which is kind of incorrect because the public networks are also finalizing the transaction and putting it there, but the transaction finality takes a lot of time and a lot of iterations, which is not the case in Hyperledger Fabric. Then designed for cryptocurrency, so conventional blockchains are designed for cryptocurrency, while in a permissioned business network, you need not have the requirement for having a token or a cryptocurrency. Obviously, when you have the open standards which are used by anyone, then you have poor governance. So the standards are not modified as per the new needs in a timely manner. While, if you see Hyperledger, every 2 months, 3 months, you will see new releases coming in with a very new set of features. And there is no privacy because it is public in nature. So these are the goals. So you can create a enterprise grade open source distributed ledger framework and code base to support business transactions, provide neutral, open and community driven infrastructure supported by technical and business governance, build technical communities to support, develop blockchain and shared ledger POCs. So, the communities for all these blockchain networks are very strong. So you can subscribe to any of these tools, any of these blockchain networks community, and you will get the regular updates of the features that are getting incorporated. And in case you are facing of any issues, you just need to go to participate and join a working group. So this is what you need to do in order to join these communities. You can follow them on various social networking platforms and just subscribe to various updates that are coming. Educate the public about the market opportunity. So one of the key goals of Linux Foundation and Hyperledger is also not only creating the different blockchain applications, but also sensitizing the world that what is the importance of blockchain and how the future applications is going to look like. So you will find various channels in the YouTube which are basically promoting blockchain technologies for different sectors that are created by Linux Foundation or Hyperledger Foundation. So you should go through all those videos to basically understand that what are the different possibilities of applications using the Hyperledger framework. Promotion participation of leading members of the ecosystem, including developers, service and solution providers. So if your organization is a member, so there are different categories of member, like you can be a gold member, platinum member. Accordingly, you will have a say in creating the new standards. If you are a standalone developer, then you will have a very limited say, although you can participate in the various development activities of new standards. These are the three categories, and it has changed a lot since the creation of this slide. So your infrastructure can be on your Cloud Foundry, which is a cloud platform. It can be on Node.js. It can be an open container. So one more thing which I think, need to know is that you can create multiple peers, multiple nodes, multiple services in a Docker container environment. You need not have the different node running. Like for example, in Ethereum, if you want to have the real Ethereum network, you will need to create the nodes that exist on different machines, maybe on different VMs, but they have to be on different machines which are reachable from each other. In Hyperledger Fabric, even if you have 100 nodes, you can have them on a single machine by using the Docker container model. So Docker container allows you to basically create instances of your nodes as a service on your single machine. The infrastructure can run on Docker container model, where you have different containers for your different peers as well as your ordering service, etc., etc. Then you have different frameworks like your Hyperledger IDE. IDE is basically mostly used in identity-related blockchain implementations. So taking your identity or digital identity on a blockchain is one of the biggest use case of blockchain. And Hyperledger IDE is specifically created or specifically designed to create the identity-based blockchain network. So if you want to create any kind of a KYC system, you will probably choose Hyperledger IDE as a platform rather than using any other Hyperledger platform, because it is customized to create such applications. So I was mentioning about Hyperledger IDE. So Hyperledger IDE is specifically meant for identity related issues. If you want to create a KYC based system, if you want to create a Aadhaar based system, probably you will create those implementation in Hyperledger IDE. Hyperledger Iroha is if you want to create a mobile based application, and that too in C++. If you want to create a mobile based application, then Hyperledger Iroha is the best suited platform for that. Again, this is not very widely used because this is still in development phase. It's not very stable, but any kind of a mobile development is preferred on Iroha. The primary contributor in Hyperledger Sawtooth is Intel. Intel uses a proof of elapsed-time consensus algorithm in Hyperledger Sawtooth, which is only possible in case of Intel platforms. So whenever you are having a Hyperledger Sawtooth based implementation, you will generally find the hardware as Intel platform. So Sawtooth and Hyperledger Fabric are the key competitors in the market. While Hyperledger Fabric is number one in terms of business application, Hyperledger Sawtooth is number two. Hyperledger Fabric is promoted by IBM and Hyperledger Sawtooth is promoted by Intel. but they are all open source. So anyone can use anything. So even Intel can use Hyperledger Fabric, and even IBM can use Hyperledger Sawtooth. So that's not a problem. But the primary contributions are from these companies. And then Hyperledger Burrow, again, this is something which is rest of your Hyperledger implementations are just kind of for study purpose or maybe for testing purpose or for research purpose. The most common ones which are used are Hyperledger Fabric, Hyperledger Sawtooth, Hyperledger INDIE, and in some cases Hyperledger Iroha. And then there are different tools that are available like Hyperledger Composer. Now, Hyperledger Composer is one of the most widely used tool in Hyperledger. But now this tool has been deprecated by the Hyperledger organization because the maintenance cost of this tool was really high. So therefore, no newer versions and no newer support of this tool is available, and you will not even find this tool listed in the Hyperledger website now. So in the projects, you will not find Hyperledger Composer, while this was one of the most famous used for creating the Hyperledger smart contract. So we will still use it because it's part of your curriculum, but it is no more supported by Hyperledger community. Hyperledger Explorer is just like your Bitcoin Explorer or Ethereum Explorer, where you can see different blocks getting created, different transactions getting committed. So Hyperledger Explorer is that similar to Bitcoin Explorer. And then you have Hyperledger Cello. Hyperledger Cello is basically a tool where you can create your infrastructure components, your peers, your ordering services in a plug and play kind of environment rather than creating them from a command line or creating them through the configuration file manually. So it's kind of a blockchain as a service kind of a platform. Although it's not completely blockchain as a service, it's a very simplified form of blockchain as a service. If you want to see blockchain as a service platform that then you should also be seeing some of the complex implementations which are available like IBM blockchain platform. So that is currently #1 blockchain as a service platform. This is blockchain as a service platform. So although Hyperledger Fabric is free, but if you want to use it as a service and if you want to quickly create your network without getting into the hassles of modifying the configuration files, setting up the various things and coming up with the problems and things like that, then this is the way to go. Although this is a paid service, but you can easily create your network in the matter of few clicks. So this is kind of a wizard which is available, and you can just say next, create your network, deploy your smart contract, and you are ready to. So this is one platform. There are other platforms also which are available where you can use blockchain as a service. So this is the scope. Now this is the high level architecture of your Hyperledger Fabric. So you have a membership service. Within the membership service, you have the registration. Registration means you can register the users. You can have the identity management, what all level of access will those users have. And then you have auditability, where you can at any point of time find the complete trace of any individual doing any activities in the network. So what all transactions I have initiated, what all transactions I have endorsed, etc., etc. At any point of time, you can audit because you are storing each and every transaction on a blockchain network. So auditability is the default feature that comes with membership service. So your membership is one layer, then your chain code is another layer. So chain code basically means your smart contract. Smart contracts are basically deployed on your secure container using the secure registry. So smart contracts are also secured by the digital keys before they are deployed, and they are deployed under the Docker container model so that they are more secure and easy to deploy. And then you have a blockchain layer where you have a consensus manager. All this you can see that they are modular in nature. Modular in nature means you can take out any component and bring in a new component very easily. So you have a consensus manager which basically tells you what kind of consensus algorithm you are going to use. By default, it is PBFT. You can put any other consensus model. If you want to have proof of work, you can put it there as well. Then there is a service for distributed ledger, how the various nodes will store the information. So there is a service for that. There is a service for point-to-point protocol, how the information will be exchanged from one peer to another peer. So that is also defined. And then there is a service for ledger storage, how the storage will look like, that will be storing your database. So all these are running as services that can be plugged and played. So you can remove any of these services and put whatever service you want to put. So membership service, it provides you registration, it provides you identity management, where you can see the assurance and authorized disclosure of association of identities. So if I am authorized to do a particular role in the network, then somebody else will not be able to do it on my behalf, because only I can do it. And then there is a auditability, because you have the complete trail of information, so you can always find the information. Okay. Now for point-to-point protocol, it uses something like HTTP kind of a service, where the messages are transferred from one node to another using HTTP protocol. The data structures are optimized to provide efficient schemes for maintaining the world state replicated at many participants. So as I mentioned, it is basically stored as level DB or 𝐂𝐞-𝐁𝐚, and different consensus algorithm may be plugged in and configured for deployment based on what you want the network to look like. Chain code, this is basically your smart contract piece of code that lets you interact with the network shared ledger. Whenever a transaction is invoked on the network, the function in the piece of chain code is called that reads and writes the value to the ledger. This is generally present only at the endorser nodes and not at all the nodes. The chain code services uses Docker to host the chain code. So as I mentioned, by default, you have Byzantine fault tolerance initial releases, but you can always plug and play. Now, this is something that we covered as an overall flow. Although it is not given in a comprehensive manner here, we will go through this complete flow in a documentation that is available in my notes. There are some very good articles present in the Medium. Medium is a blogging site which keeps articles for various different technologies. So especially for Fabric, I find very good articles here. So if you really want to see that, how the Fabric architecture looks like, you should actually refer to the diagrams which are there here. This is how your typical architecture looks like. You have a chain code installed at endorser nodes, and then you can have different channels, and you have the ledgers. Based on the complexity of your design, you can have various kind of architectures. This is the most complex one that you can imagine. You have this ordering services running here. You have these endorser peers and committer peers here. You have two different channels, channel A, channel B, you have 𝐂𝐻DB, you have level DB, everything is there in order to understand the design completely or the architecture thoroughly. But now what it says is that, the client delivered the transactions to the pending pools. So basically it reaches to the endorsing peers, which is not given here, but, it goes to the endorsing peers. Now transactions are sent for application, selectively apply the transaction. So its smart contract is basically applied, and a return of proof of correctness or a change set is given back to the application. So the endorser nodes will run the smart contract or the chain code, and they will return back with the proof of correctness, whether the transaction is correct or not, and what all data needs to be written. It will give it back to the client, and the client will again broadcast the ordered list of transactions through the ordering services. So it will give it to the ordering service, and ordering service will order the list of transactions along with the proof of correctness and the change set to the other peers. These other peers are known as committer peers. And these peers, where you are running this smart contract, are known as endorser peers. And this is how you notify, and then you notify the events to various clients or applications that are there. So the generalized Hyperledger consensus process flow. So ordering means basically, collecting the transactions and creating the block and doing various kind of like Merkle tree creation, hashing, etc., and transmitting those blocks to the committer nodes. And then validating is when you are validating the information that are coming in the nodes in form of the transaction. So by logically separating these activities, we ensure that any Hyperledger framework can work with any Hyperledger consensus module. So again, this is for the sake of plug and play. If you want to change the ordering service, you can easily just remove one ordering service and introduce a new ordering service. So the way you have Web3 APIs in Ethereum for connecting with your front-end applications, similarly, you have the REST API interface in Hyperledger Fabric for connecting with the external applications or connecting with the user interface. So REST API is basically similar to your Web3 interface, where you get a set of APIs that you need to implement, and then you can call the functions of your smart contract directly through those APIs. So SDK is available in Go language, JavaScript, and Java. So it is not only in Go, Java, JavaScript. You can also have a SDK available in C++, Node.js, various other languages. Additional programming languages can be added as necessary. Again, this is something that we have already gone through: identity, addresses, transaction, chain code, blockchain, network, storage, event. And there are APIs available for interacting with all these entities in blockchain. If you want to break down an application into different logic, so you can see that you have 4 logical models which are available. One is your view logic, where you connect your backend with your front end, and so that is done through the help of REST APIs in Hyperledger Fabric. And then there is a control logic which coordinates between UI, data modeler, Hyperledger APIs. So it is created in a modular way because so that you can easily write your portion. So for example, if you are a blockchain logic developer, then you will essentially focus on writing your smart contracts. If you are a data modeler, then you will focus on basically writing what kind of databases we have in this blockchain network and what level of accesses needs to be given on those databases. The newer model of blockchain also supports a completely relational database to be incorporated along with your normal blockchain database. So data modeling is getting really, really important in blockchain-based scenario also. And then the control logic and view logic are basically incorporated by your UI developers. So that's how your application looks like. It can be hosted on any kind of a hardware or network. So you can have it hosted on a cloud. You can have hosted on cloud hosted multiple networks, as long as those nodes are connected with each other through some mechanism. As long as you can ping one node from another node, they can be part of different cloud-based network as well. So multi-cloud network based on blockchain is again one of the most upcoming use cases in the market, where most of the companies are now going on hybrid cloud models. They do not rely on one vendor or one cloud for supporting their infrastructure, applications, and software. So how do they interact between multiple cloud vendors? Chain is one technology that everyone wants to use. So multiple networks hosted on cloud, they generally connect it through blockchain, and the participant hosted intranet or a singular network or your default infrastructure that is available in your organization can also be used to deploy the network. So it can be on cloud, it can be on any kind of a hardware, it can be on multi-cloud as well. So Iroha, as I mentioned, is most suitable for mobile and web-based development. So if you are creating a blockchain-based application on your mobile, then probably you should use Iroha because it gives you the direct implementation and design formats that can be easily used to create the mobile applications. However, if you see practically, at least I have not seen any practical implementation coming out from Iroha as yet. In fact, for that matter, I have not seen a realistic application which is available on Google Play or your iOS platform, which is blockchain based. So most of the applications that are currently running are either web-based application or running within a particular organization. They are not on a mobile as yet. But Iroha gives you the functionality of easily creating such applications. With respect to the features, if you compare it with Fabric and Sawtooth, in that case, it stands nowhere. And also because it uses C++ as a language, which is a bit older language, it does not have those kind of functionalities available, which you generally see in JavaScript or Node.js. So why Iroha? If you want a simple blockchain-based implementation to run from your mobile device, then only you will be using Iroha. Otherwise, you will not be using Iroha. So currently, Hyperledger project lacks an infrastructure project written in C++, thus limiting the potential developers who can contribute. The C++ is no more used widely. Iroha aims to rectify both these points, bringing more developers while providing libraries. And this is not currently a strong focus on user interaction on mobiles, though both are necessary for realization of widespread use of DLT. So if you are a good C++ developer, and if you want to write something on your mobile application based on blockchain, then use Iroha. Otherwise, it is not a suitable candidate. Fabric is the most often used one. So Fabric is a permissioned blockchain network implemented in Go programming language. Although the Fabric network is implemented in Go programming language, but the smart contract can be written in any language where the SDK is available. So made for enabling consortium blockchains with different degrees of permissions. So we have public, we have private, and we have consortium. So private and consortium networks are primarily created using Hyperledger. Modular architecture delivering high degree of confidence, resiliency, flexibility, and scalability. Support pluggable implementations and accommodate the complexity that exists across economic ecosystem. Delivers uniquely elastic, extensible architecture, distinguishing it from alternate blockchain solutions. How Fabric works? So Fabric issues transactions with derived certificates that are unlinkable to owning participant. All parties must register to proof of identity to the membership service in order to gain access. The content of each transaction is encrypted to ensure only the intended participant can see the content. So each and every content is digitally encrypted using the public-private key as we have in Bitcoin and Ethereum. All transactions are secured, private, and confidential. Fabric can only be updated by consensus of the peers. The transactions are executed without a cryptocurrency. The events are structured as transactions and shared along with the different participants. It relies on the smart contract system where each peer of the network run in Docker container. Sawtooth Lake, as I mentioned, is primarily promoted by Intel. It is designed to explore scalability, security, and privacy questions prompted by the original distributed ledgers. So the key distinguished feature of Sawtooth from Fabric is the consensus algorithm, which is proof of elapsed time. So there is a random chance that every miner gets for mining the block, and it is based on the random number that is created by the Intel hardware. So it maintains the security of platform by allowing businessmen to create private blockchains. It is additionally exceedingly modular. This empowers enterprise and consortia to settle an agreement choices that are best prepared to make. Now, apart from this change, it also has a concept of transaction family. So while you can have hundreds of different transactions, in Sawtooth Lake, you can categorize the transaction or a group of transactions under one transaction family, and it stores those transactions in such a way that you can easily fetch up information of one transaction family without basically running multiple queries. That is another advantage the Sawtooth Lake has, that it accumulates all the related transactions into a common group, and it keeps track of how they are stored in the ledger so that they are easy to retrieve. Sawtooth Lake, again, I will recommend that, if you should choose one among these, like, either Hyperledger Fabric or Hyperledger Sawtooth Lake, and you should try to gain a complete mastery in either of these two platforms. Hyperledger INDIE, as I mentioned, it is basically for identity-based solutions. Identity is one of the critical use case for blockchain implementation, and INDIE is designed to basically store different kinds of identity, be it your basically educational credentials, your identity-related credentials like your birth certificate, your passport, etc. All these things are easily incorporated in Hyperledger INDIE. In fact, there is a product by IBM on digital identity which use Hyperledger INDIE. This is the product that IBM has developed, and this is developed using Hyperledger INDIE. Decentralized approach of identity management, and I think it must be mentioned somewhere that this is developed using INDIE. KYC, you can see that how the KYC is happening here. I'm not sure where it is mentioned, but it is developed using Hyperledger INDIE. So you can even try this solution if you want that how it actually looks like. I'll just ping it across the chat. So INDIE is all about giving identity owners independent control of their personal data and relationship built so that the power of identity is structurally part of the transactions made about that identity. Pairwise identities not only prevent correlation but stop third parties from transacting without the identity owner taking part. Indy shares three important virtues with the internet. No one owns it, everyone can use it, anyone can improve it. Validation is performed by the set of validator nodes running a modified redundant Byzantine fault tolerant problem called plenum. So this is the consensus algorithm which is used in Hyperledger Indy. It is called as plenum. It is a variant of Byzantine fault tolerant protocol. And plenum allowed for the group of servers run by the validators to come to a collective agreement about the validity and order of events. So each and every implementation, you will find some unique consensus algorithm, and that's the key distinguishing factor of any blockchain. It will have a different way of achieving the consensus. Now, Hyperledger Burrow, this is more of a kind of test network, and this is, so if you want to run your Ethereum contracts on Hyperledger, then this is a platform which is available. So you can directly use your Ethereum smart contract, and you can run it on a Hyperledger framework using the Hyperledger Burrow. But this is not very promising, and this is not very often used. So Celo, as I mentioned, is basically blockchain as a service platform. It can allow you to easily create your peers, your orderers, your committers, your MSPs, your certification authorities. You can define that, which piece of hardware will act as what all software or what all chain codes needs to be installed where. And basically it will give you the data with regards to your health and analytics feature by default, which are built in, that how this peer is behaving, how many transactions are endorsed. All those things you can see on a Hyperledger Celo console. If you want to use these tools, there is no basically executable that is available. So what you will need to do is you will need to download the source code of this tool, and then you will need to compile, execute, and then use it. You will not get a binary to basically use these tools. Go to hyperledger.org and you go to Hyperledger Celo, and same is for Hyperledger Explorer also. So if you go to Hyperledger Celo, you will see that you cannot download anything. You can get the code in the GitHub, and from the code you will find the instructions to basically compile and run this tool. Then Hyperledger Explorer is same as Bitcoin Explorer. Again, in order to use this, you will again need to compile this and run this. You cannot get the executable or a binary source directly installable. This is Hyperledger Explorer. You will need to get the code. This will direct you to the GitHub. Then you will need to compile and run it. I think with that, we have covered a lot of ground today. So that's it for today. Thank you so much.